Hello, friends. Today, we will solve a maze challenge in Python programming. This is a challenging problem from a website named Reeborg World. You will find many Python programming challenges on this site. The link is available in the description. Go ahead and open the site. You can even develop small games on this platform. Now, search for maze in the select bar to open the maze problem. In this challenge, the robot needs to reach the flag through programming. Each time, the robot's starting position is random. Therefore, logic should ensure that the robot can reach the end from any position. Notice that the robot's position changes every time I start the program. All right, let's first understand some of the pre-built functions. Click on Reeborg's keyboard. You'll find supported commands there. In the Commands tab, you'll see many functions like move and turn left. In the Conditions section, there are functions such as at goal, front is clear, and wall in front. The Python tab contains basic Python programming blocks. Similarly, the Objects tab includes objects you can use to create custom games. Lastly, the Special tab provides operators and symbols. Now, let's dive into programming logic. In this logic, we'll make the robot follow the right wall to reach its destination. If the robot starts here, it will reach its goal by sticking to the right wall. Let's go to the Programming tab and develop our logic. Notice there's a turn left function, but no turn right. Since only basic functions are available, we can simulate turn right by executing turn left 3 times. Let's create a Python function for turn right and test it. We'll also add a move function to test the combination. When the program runs, the robot turns 3 times left and moves forward by 1 block. Since it hasn't reached the destination yet, we get an error. Now, how do we check if the robot has reached the goal? The @goal function in the Conditions tab does this for us. We'll use a while loop to keep the robot moving until it reaches the goal. The loop runs as long as @goal returns false. To invert this condition, we use not before @goal. Understanding the conditions. Condition 1. Check if the robot's front is clear and there's a wall on its right. Use the front is clear and wall on right functions. If it is true, we move ahead using the move function. Second condition, suppose the robot faces walls on 3 sides, front, right, and left. We use the wall in front and wall on right functions. In this case, the robot should only turn left without moving forward. Condition 3. If the robot's right side is clear, it should turn right and move forward. Now our code is complete. Let's test it. Oh no, it's stuck in a loop. Let's debug. In condition 1, we forgot to write the wall on right function. After adding it, everything looks correct. Let's run the updated program again. Perfect. It worked flawlessly. Let's test it with a second starting position. It worked perfectly now. Let's try one more time. Amazing! Hope, you found this maze challenge interesting. You can apply this logic to build a real-world maze-solving robot using a wheeled robot. If you'd like me to make a video on that topic, let me know in the comments. Now, let's explore another problem. Hurdle 4. This is the hardest of all the hurdle challenges. When I first solved it, I used a different approach. But surprisingly, the maze-solving logic worked here as well. This problem is challenging because the wall height change randomly. Let's run the program. It worked seamlessly. Let's also try Hurdle 3. It's done. You might wonder why the maze-solving logic works on hurdle problems. The reason is that, like a maze, a hurdle has a destination on the right side, and we have used the right wall-following logic. Hope you learned something today? Try different problems on Reeborg's World. If you face any issues, feel free to ask in the comments. See you in the next video. Happy coding!